When you install a Python package using pip, it's typically installed from a file format called a wheel. Wheels are the standard for how Python packages are distributed in a convenient archive form rather than in just source. In this video, we're going to take a look at how to make wheels from your pip installable Python projects and how that makes it easier to distribute your Python projects to others. Let's start with this simple pip installable project I've been using as a case study over the last couple of videos. This project can be pip installed into a Python environment, but only if I have access to the source tree. It's not always convenient to give the source to someone else, as is, and I can't upload it to PyPI in this form either. So to make a wheel from this project, the first thing I need is a tool called build, created by the Python Packaging Authority. These are the folks who set the standards for how Python project packaging works. Build is not included by default with Python because many people will use Python without ever building a wheel. Now, I recommend creating a separate virtual environment for the sake of building wheels from your project, one that you can install the build tool into, and one that is distinct from the environment that you use to develop your project. I have created just such an environment here called wvenv, so we're going to use that. To install build in the environment we're going to create our wheels in, we just use pip install build. Note that it installs some other packages along with it. That's normal, and that's also why I recommend using a separate venv for the build tools so as to keep them from conflicting with anything in your project proper. Next, we're going to use build to actually create the wheel, and that is easy enough. We just run build as a module, py-m build, in the directory for our source. Now, a few things happen when we run this. First, you're going to see detailed output from the build process to the console. And second, you're going to see new directories appear in your project tree. One of them is named dist. Dist contains a couple of files. One is the whl file, that's the wheel created from our project, and the other is a tar.gz format archive. The difference between these two is really important. The wheel is what's called a built distribution. It's been pre-configured to run as is on a particular platform, in this case 64-bit Microsoft Windows. If you have, for instance, components written in C for a given platform, they're going to be compiled and placed inside the wheel so that the end user doesn't have to do that themselves. The default behavior with build is to create a wheel for the currently running platform. If you want to cross-build wheels for multiple platforms at once, for instance, to build Linux wheels if you're on a Windows system or vice versa, you can do that sort of thing with things like GitHub Actions and a Python packaging authority tool named CI build wheel. That's worth a whole video unto itself, though. Now, in case you're curious, the wheel format is just a zip file under the hood, so you can open it and spelunk around inside it with a garden variety archiving tool like this. The tar.gz archive, however, is what's called a source distribution. It can be used to build the project from scratch on a target platform, including things like binaries for that platform, as long as the build tools are available for where it's being built. The default, though, is to use a binary wheel. The source distribution is a fallback that the Python tooling uses in case you try to install a package on a platform that has no binary wheel built for it. To demonstrate how the building process works further, I'm going to show you another incarnation of this project, but that uses a module built in C with Cython, so it has a truly binary component to it. The C module is very simple. It just performs a little math, and it's mostly for the sake of demonstrating the build process. To make it work, we have to modify our pyproject.toml file correspondingly to indicate we have build instructions for it, and we also have to provide a setup.py file for the sake of Cython. Now, when we run build on this version of the project, you may see how Cython is invoked to compile the binary components for the sake of the wheel. Only the wheel includes the binaries, though. The tar.gz archive does include the generated C source, which makes it easy to build the project on a system where Cython isn't installed. But it does not include any of the platform-specific generated binary components. It's a source distribution, once again. Another thing worth noting is that when we build a wheel that has binary components into it, you'll notice that the name of the wheel indicates the platform that it's supposed to run on and the version of Python that it's tied to. In this case, Python 3.12 and the AMD 64 that is the 64-bit version of Windows. Now with our other wheel, the one that is pure Python and has no binary components in it, you'll notice it has pi3 none any as its descriptor. And that means this will in theory work on any version of Python version 3 and any platform. Again, because there are no specific components in there that tie it to a particular version of an operating system. So to sum up, wheels are the archive format we use to distribute Python packages. The build tool lets us create them from our own packages, and the resulting built wheel can include binary components for specific platforms and architectures. And that's it for this episode. If you liked it, leave a comment below, and don't forget to follow Dev with Serdar and InfoWorld on Facebook, YouTube, and Infoworld.com.